What we're going to talk about are these loose tenons, and they're these guys here. They're any kind of homemade tenon extension of material of wood that we're going to fit into a slot that we're going to cut into the end of the rail and into the leg. But I've got this tenon we made. It fit nicely into this leg. But this is a great joint, as we mentioned last time, because the tenon, this extension of wood, is actually part of the rail. It's just an extension. So you've got to trim away the shoulder material all around and leave a tenon extended. We used the method on the table saw to first cut our cheeks, and then we turned it and laid it flat and cut the shoulders, getting a nice, true fit as it went up. But in the production world, they don't do it that way. They have much more efficient ways of setting up, where typically it's a high-speed router that comes in from the end and trims around in this fashion. I'm sorry, I can't remember if I mentioned that last week. But the reason that's so slick and effective is, if you think about it, the router is spinning, I think it's 20,000 RPMs, like at the highest speed. And the bits are generally around a half an inch to do this. And they come out and they move around the outside of the piece. And the reason it's so great is because there's really little stress on the router bit, because all the fibers are running this way. And it just is knocking them off like they're just standing there. It doesn't have to cut across them, really. It's just the bottom that's trimming the very base of those fibers smooth and flat. So a production tenoner is really something to see, because usually they'll just digitally dial it in and it'll go running right around. A good friend of mine had a shop like that, and it was amazing. They would just plug in the numbers and come out. So you really have to be making a lot of tenons and tables and chairs or whatever to justify the cost of that. I think that machine was, I think he said it was around 40 grand. Now, there are other machines that you can get. One is called the multi-router. I think I'm saying that right. The multi-router. That's been on the market for probably 25, 30 years. It's a really nice piece of machinery. It's actually just some cast iron or steel, and it's a very nice setup where you clamp, a router goes into the end, so you have a router horizontally making your cuts. Now you can cut mortises with it, and you can cut around the tenons. If you're going to set up, that's a pretty nice system for a small shop, and those go for just under 3 grand. But so you can see why I prefer like a hollow chisel mortiser, which the bench top is around $500, something like that. Or tonight, I want to show you how you can use your router to make floating tenons. And this method is pretty slick, and as I said in the description, it's almost as strong and as good as a true mortise and tenon. Now, I'm going to show you just a couple different methods. There's a lot of ways to apply this, but I just want you to get the gist of it. I'll show you one with the router, and then one with the Festool Domino, which will probably be a bit of a tease because they are a wonderful machine. But what I want to start out with is to show you the use I made of some floating tenons as I built this Adirondack chair. This is actually the chair that I made. This is a prototype, just a mock-up in poplar that I put together to see if the concept was going to work. And this is the actual one that I worked on before I made one in Cyprus. I had the drawing all worked up and I messed around. I actually had an arm like this. I had the flat arm that went around. So it was more traditional. Of course, this other arm wasn't in the way. But I tried this method because I was trying to eliminate the complexity of this sloping joint right here. You know, how much can you do? How much could I do on the show? How is it really necessary? But you know, once I got that on there and I had it screwed on for the prototype, I sat down in this chair, and the one thing that bugs me about some traditional Adirondacks was true. It was too high on the elbows. So I'm sitting in there, and I'm kind of like this, and some of you may remember, I'm dating myself with this, Edith Ann. Some of you remember, but I felt a little like, you know, you get that little Edith Ann feeling with your elbows up like this. It's just a little girl sitting in a way too big chair. So anyway, I decided to add the slope because it's pretty cool. Gave an opportunity to make this funky little spline joint. But I also really liked the way that the slope of the arm related better to the curvature of the side rail, which is really the main design feature of this chair, that sweeping curve. So in assembling the chair, I had to think, all right, how am I going to put this together? Well, it was the perfect kind of candidate for floating tenons. I didn't want to make it too much like real furniture. So I know it is real furniture, but I mean, sometimes you think of outdoor furniture as stuff you don't really, you know, it's second rate. And, you know, some people had their little critique about Adirondack. Why don't you just screw it together? Well, because I don't want to screw it together. Everybody else is screwed together. We're not screwing it together. We want it to last some time and have a little pride in what we're making here, right? So I didn't even want screws to be visible. So you'll notice in the finished chair that they're not visible. So we've got the arm assembly, which is still screwed in there. So I'm just going to lift that. It will go on its side when I pull this leg off. So I'm going to pull this right off that side. There it is. Okay, so that's not bad. Now it's all coming apart. This is not the way we assemble and disassemble. But that's the chair. These are all the slats back here hiding. So let me show you, we've got the side rail here. And this is the way I designed this. It ended up, I wanted to try to simplify and compress all the procedures to make it a little more intuitive, almost the way we build this. So one of the ways we start in making this is to make a template from the full-size drawing. By the way, this chair was also in the article in Fine Woodworking. They also have plans which are digital and not full size. But of course, I'm biased to the full size. I love Fine Woodworking. But the full-size drawings give you a direct connection to the actual shapes and dimensions that are on the original chair. So this pattern is actually taken right from the full-size drawing by using a stippling method. And it's quite straightforward once you do it once. I think I've used that method in quite a number of projects. But once I have the outline of the chair, I also then locate where I want to put the long groove for the seat rail, the seat rails in this chair. They go in like that. And these two spots, which are really what we wanted to focus on, these are the slots where we'll plunge out for the floating tenon. This one for the back rail and this one for the front. So you can see this isn't actually how the front rail ended up. I ended up pushing it more forward. It was too far back on the original, and I didn't need to, angle that piece there. It ended up being more centered and a little wider. But you can see that this has an angle cut on the top. Let me show you from the bottom. So it's angled like that because this chair gets narrower as you move from front to back. So here's the mortise on the front side, and we can see that this tenon, let me see, did I glue that in? Yeah, I'm going to pull on that really hard, and it's never going to move because it's glued in. But that tenon goes right in there, and we get a really nice joint. So, but I didn't have to cut around this shoulder. I just cut this piece exactly to that angle and squared it and cut straight across. No concern for the tenon. Actually cut it the exact length I wanted, which I believe is 22 from the long point across, and then hit the angle. I think it's around 7 degrees, or I forget. But then plunge routed that tenon so that it emerged on that surface at 90 degrees to this surface. And then this was plunged perpendicularly in, so when they come together, the joint comes together really well. So the nice thing about a floating tenon in this case is it simplifies the joinery greatly. Like, this is actually a compound tenon because it's not coming out directly square. You actually have it coming out at an angle, and there's an angled shoulder as well. But the shoulder surface right here, that end surface, in this case, and whenever you're making any floating tenons, you want that shoulder surface to be 90 degrees to the tenon that's coming out from it. If you've got that, and you've got, like in most cases, your other plunge will be 90 degrees, then you know they're going to interlock and come up really perfectly, even though it's a compound joint. Okay? So that's the real beauty of floating tenons, is they can greatly simplify complex or compound joinery in angles and in curves, as I'll show you a little bit in just a little bit. So we've got our template here, and all I did for this, to make this template, I'll show you, I'm going to use a router to just demonstrate one connection here. And this is a collar. Actually, you buy these guide collars for your router. You get usually a set like this. They come in all a range of sizes. You have your outside diameter and your inside diameter. And so you just choose the appropriate one for the router bit that you'll be using. Now, in this case, I've got one that's a 5/8 inch outside diameter. Double check. Yes. 5/8 inch outside diameter. And the metal wall of that is only about a 32nd thick, maybe slightly more. So a 1/2 inch cutter will fit really nicely inside here. So that's what I'm going to use for this. Now, this collar, it just fits. You can interchange them, switch them out easily. Most plunge routers will have a housing or a fitting to accept this collar system. Okay? Some are brass, but I've had a couple different sets over the years, and I found them to be very, very true and reliable, you know, as far as the outside diameter and the centering of them goes and all that. So we've got the 5/8 inch in there, and I'm going to use this router. This is pretty sweet. I mean, my DeWalt router has a plate like this. This is probably how most of them are. And so when I want to use the guide collars, I use this heavy circular plate that gets screwed onto the base like that. And the guide collar seats in here perfectly, just like it's seated in here. They come that way. It's kind of a universal fitting for those guide collars. So that has to be screwed on and off, and it's not bad. I've actually enjoyed it for many years. But I do like this, the way arrangement here on the Festool, because I've got my 1/2-inch cutter in there, and you can release this plate and it just snaps in. That's pretty sweet. I've got my 1/2-inch bit in here and my 5/8 inch outside diameter. Now I've already set the depth so that with the pattern, so that guide call is going to ride in the pattern, and at the full plunge depth, which it's set right there, it's going to cut a 5/8 inch depth hole. It takes some time. It's because you're not just screwing everything together. You're making it to last like this. I'm not actually going to cut one of these because you may have noticed those don't line up with this, because this was the mock-up and it didn't end up exactly that way. So this is the final, this is the true pattern that I used. But I want to show you the method I used to cut this tenon on the top, because it's basically the same, but it uses a little different template. So this is the top of the one of the arms here. I mean the front legs, and you have your floating tenon fitting just like that. And it's a 1/2-inch wide, and I'll tell you about that in a second. But I'm going to just demo it on the bottom so I can show you how I did it. So I'm going to put it in the vise and just face up. Now you notice I made, you see those? I made a center line in both directions because I want this mortise to be centered in that space. And by just using a pencil line with my little square, I mapped it out. Okay? Now I'm going to take this little template, and this is made just the same as those other slots. So this length of this slot is the same as what we use for underneath the arm, because this would be, if you imagine this is the top of the leg, it connects under the arm where you have a corresponding slot. I put it to the side. So this is my little template. I have a center line down the middle of my template and a center line this way. So this is a pretty quick way. I could put a straight edge, attach it to my template, but it's not that critical here, because even if you off slightly, it will give you a slight twist. It's not a big deal. But you can eyeball it very accurately. I can get it right aligned with the pencil lines, looking both directions. It's like setting up a bullseye, but it's quite easy because everything aligns nicely. And then I'm just going to tap those brads in. So because it's 1.25 inches wide, it's a solid enough foot that it's not going to rock. I'm just going to stay, all my pressure is right in the middle, and I'm going to be plunging down the middle, moving front to back. All right, so let's give this a shot. All right, so I'm going to raise up my plunge. The difficulty here is that there's not a lot of room for the chips to come out. So with this cut, they want to clog in there. That's why you often see, if you're going to do a lot of this, it's worth investing in an upcut spiral cutter. This is a spiral cutter, actually a 1/2-inch cutter. You may be saying, why did you put that in? Well, because this is a down cut. And this actually, as it spins, it forces the shavings down. Now, the reason you'd want that is because it leaves a very clean surface on the top. So it's shearing downward, so you don't get that tear out or fibers lifted out the top. These are pretty handy. But the one I'm talking about is spiraled the other direction. And as it spins, it actually lifts the shavings out. So if you had like a little vacuum set, or you're going to do a lot of plunging, that's pretty ideal for this type of setup. But I have a straight one right here, so it requires you stopping a little and cleaning it out. Here we go. You can see how we're getting that nice cut. Now I'm going to start this end. All right, there you have it. Then you just have to pull this off and you're all set. So that leaves like a nice 1/2 inch slot, and we did the same to the opposing pieces. Everything's got its mortise in there. And then you need to have your tenon material. So see, that fits sweet. But the way I make this is I just take some, I used oak in this case, super strong, and I just dimensioned it, you know, a little less than the length. So the length of these slots ends up being just over 2 1/4, and I made this 2 1/4. So this is a little over, and all I did was run this through the thickness planer, and if you have a thickness sander or drum sander, that's excellent, because you can just pass it through and then test it in a sample mortise to see how it's fitting. Now usually I leave them a little snug, and I prefer to just final sand as I'm fitting them, where you can just scuff them across a piece of sandpaper like this. I just glued the sandpaper to a block. It's like 150 grit, and it just quick to fit them. So once I cut this, I've got this dimension to 2 1/4 by 1/2 inch, and I've tested it to fit my mortise. Then I'll set, if I've got a lot of these, I'll set the table saw blade to 45, and I'll just skim or chamfer if you're from England, but I'll chamfer the corners, which simulates the rounding over so it'll fit, and we're getting the full length. See how tight those look? And they're almost right to the ends, and you get a really good use of that fit. So that's a big, strong, homemade tenon. Now, I would take it to the bandsaw, and then I just cut them off like this. Should have something to push it through with. Nothing like a good chair part. Here we go. So then you've made your own floating tenon. So these go like 5/8 in here and 5/8 into the rail. So they're just about 1 1/4 inches in length. And then what I like to do is knock off the edges here so that it's not really sharp going in. And you're taking off any kind of resistance so that when it goes in, it's not pushing all the glue. And look at that, really nice fit. Pretty sweet. That is a floating tenon. Now, when I'm assembling and gluing up, one of the things I like to do is glue in the tenon to the long rail. So the rail where the grain direction is running in the same direction, so that if you were actually cutting a traditional tenon here, this is how it would look. Okay? So if I glue that in, I just glue all those in, most of the parts. Then after it's glued in, what you have is as if you've made a traditional tenon. So when you're gluing up, when you're actually assembling, you have one less thing to glue up. So that you're just having to glue up the other side. Okay? So it just simplifies the assembly process with that. So there are many ways to use this method I just showed you. I mean, you don't have to use that template like this. You could actually have a straight edge on your router and you run it that way. It's a little harder to hold it on here because, going into the ends. Like I said, you can have nicer tooling like the multi-router or some type of horizontal boring or routing machine. There's some really nice tools out there where you actually fix and clamp the piece down. Usually it's locked down, and then the table moves into the cutter, and you move it back and forth. And you get this beautiful, accurate slot like that. A lot of small shops have good quality like that. And then, of course, the big shops are much more automated as you go to have some type of traditional mortise and tenon connection like that. But typically, they're all floating. Some actually are machining an extended tenon. So when you've got the floating, though, obviously you're dealing with these rounded edges, so you don't get the square indexing of the traditional tenon right off the bottom of the rail. You're just usually centering your tenon. So that's one way to do it. There's all kinds of guides you can set up with. One other method I've used, I'll just show you a couple things. Check this out. This was from a low console, sort of like an entertainment center, but it was a low table that had that housed a really nice sound system. So this center area had all the electronics, and the two sides had drawers for, at that time they were DVDs. But this is the template for the top and the bottom, and it's actually the template for the tambour door. The piece was a little longer than this, and it wasn't exactly this shape, but it was fairly elliptical in shape. The reason I'm showing you this is because of these. These slots are what I did, just what I just showed you. It's just a series of them. So rather than dadoing in the vertical dividers that created the vertical dimension of this piece, I just plunge routed, and these are only a 1/2 inch, so I was probably plunge routing like a 3/8 inch tenon in there, or maybe even a little less, maybe 5/16, I forget. So I would do that, just tack this to the piece, plunge route, you get all your locations. Then I plunge routed the groove for the tambour door. That's a little bonus tonight, talking about tambour doors. That groove, we'll talk about that some other time. And everything I knew was going to be perfectly aligned because I then indexed this piece up on the top and it went on the bottom, aligned the exact same way, and I was able to plunge route these. So then into the ends of the divider panels, I would then just plunge route this same spacing, marking it out. And all those panels were cut identically to length, and I put in the floating tenons on the top and bottom of those panels. And when you assembled that piece, everything was dead on because you had this template utilizing the grooves like this. And each of those panels was exactly the same length, which is super critical when making tambour doors, because when you slide open that door, it has to be perfectly aligned in height so it never pinches as it goes around. So this is just to show you the way you can, rather than dadoing in internal panels, you can use floating tenons to assemble vertical dividers in cabinets or whatever. One other application that I like using was on, this is actually a two-part. This is the side of a bed. This is showing a, what do I call it? It's not really a sleigh bed. If you want to go on and look at my videos, I called it the barn beam bed. This is the profile of that head post. These are not the joints I use on that piece. Did I? No. Uh, sorry. These are for a different style where it was tenon, but imagine I didn't use these. I actually used this setup when I made that barn beam bed, because the headboard was actually a laminated panel that was curved. And just thinking of getting the joinery in there was complicated. So what I ended up doing was tacking this to the inside of the post, plunge routing my mortises, and then I tacked this same pattern. That's actually the profile of the panel. I tacked the same pattern to that with that line indexed right through here. The exact same template now into the ends, and then I plunge routed the ends of that curved panel. So then I put in my floating tenons, and it glued right up. I had a really beautiful, strong headboard system without much difficulty at all. It's just making the template and using it on both sides so you get an accurate. Now, I'm going to put this one together. This is the traditional mortise and tenon we made last time. And I'm going to cut a fest tool. I'm going to use the Domino on this guy. So here's the fest tool Domino. And this is really kind of crazy. I honestly, when this came out, I was kind of blown away because I felt like it revolutionized the way you could make quick tenon joinery. Prior to this, it was like the best speed thing you could do was biscuits. These are like compressed wood, but they were utilizing the spinning like cutter that's only about a little over an 1/8 inch thick. So you'd usually just get at most like a 1/2 inch depth. This is the second to largest size. So the 20 is the big one. So you get that kind of depth. Not really great for a full tenon with you having the structural joinery. But then out came this Domino thing. And this Domino thing. And this, if I take off the housing here, this is the guts of it here. What it is it's like a router bit. This is the cutter. So this spins at a pretty high speed. And if it did just that, when you plunge, you just get a round hole. But it doesn't. It's got like a little mechanical connection in here. So it oscillates back and forth. So as you plunge, that thing's oscillating at a certain width, and it cuts a slot. So you get a mortise. So see, the bit is spinning at a high speed. And that's all it's doing. Now you can change the width of the sweep. I'm not getting it all the way over, but I'll just go to the second one. And that was a little wider. So you can make a wider slot if you want. But that's what it does. And that just changes the game, because if you can cut a quick slot like that, and then the floating tenons you have, which they have, I think it's beech. It's like a hardwood. It's just like maple, but they machine these so that they're really accurate to the slots that you get here, based on the cutter. This is the 10 millimeter. It's almost 3/8 of an inch. I'm going to be using, I've got the 8 in there right now, which is really close to the tenon that I cut last week. It's the like a 5/16 tenon. And it's 20 millimeters long. So I'm going to get almost the full inch, just like we did, just like we had last time. Oh no, I guess we did a 7/8 inch, so it's close enough. All right, so I'm going to use this, and I've got it set on the narrower setting. Now you can use, with this setup, you can use this and raise and lower. I like doing that when I'm working, if I'm working on panels or larger things I can clamp down. In this case, we're working on smaller parts close to the edge. So what I'm going to do is work off the bottom plate. So I'm just going to hold it flat and plunge this way. And I'll show you how that works. So the plate actually gives me about 1/4 of an inch space from the bottom of the plate to the bottom of this 8mm cutter. So I'm thinking of that spacing. Now on my tenon, this tenon, I went 3/8 of an inch from the front there. So what I want to do is I'm actually going to cut it into, I'm going to make a cut into this mortise here. We're going to cut into that where we have that slot, but we're going to make 2 little cuts for the domino here. So I'm going to go in here. Now if I just went this way, I would only be 1/4 inch away from the face. I want to get the full 3/8, so I'm just going to use a little piece of masonite that's 1/8 of an inch thick and use that as my riser block here. I'm just going to clamp this like this. Just clamp that right down. I'm going to come down, let's see, I'm marking it on the top here, and it just works out right that I'm 7/8 and then 2 1/8. So those little indexing lines are all I have to do. All I have to do is line up that line right there. That's the center of my domino slot. So just line that line up with the line I just made. I'm just going to give 2 quick plunges. Here we go. This is where this is like a production tool because of how fast it'll cut the mortise. That's that. All right, now I'm going to go into the end of this one. So I want to create a rail that'll match those 2 mortises right here. So this is my face. I'm going to put the face down. Now I want to offset this just like we did last time. So I've got like a 3/32 offset. So I've got this piece of bending ply that actually measures 3/32. I'm going to put it under here, which is going to push the mortise closer to the surface here and actually set it back from the face of the leg. So all I have to do is clamp that on here. And that's my little riser. I've already got my marks. I'm ready to go. Here we go. You notice I was getting dust there. I was thinking to myself, why is that not working? Well, it helps when you put the vacuum hose on the actual domino. Okay, so now I've got that set, and here's a couple. Whoops, that's too thick. Here's a couple 8mm by 20, and I can put those in. Now they have a little ridge on the top and bottom that makes them fit really perfectly snug. But I want to take a little of that off so I have a bit of play. So So all you have to do if you want to remove that ridge is just scuff it, or not completely remove it, but just take it down a little bit. That's it. Now we'll put it back in. And again, I would glue those in there first. And then here we go into our slot. And look at that. I mean, that fast we made what took us how long last time to make the traditional mortise and tenon. And we've got two really nice hardwood, it's really like a double high tenon into that piece. Beautiful. So some people have asked me if you could substitute dominoes to make that chair, and yes, of course. You're just going to size them appropriately. Okay. I want to just do one more. So this is a laminated curved apron. Okay. This is where the domino can really help you a lot too, because imagine putting a tenon on the end of this curved piece. Now this is laminated with some bending ply, so the grain is going both ways. I've got a combination of plywoods in there, Italian bending, and one piece of 3/8 inch wacky wood, like bending ply. But anyway, I want to get a tenon in there. To cut a real true tenon and have the angle be just right for the mortise is not easy. So what I want to do is cut this so that it fits in there. Now all I have to do is what I said earlier. I want to make sure that the mortise goes in perpendicular to this surface, because I know these mortises are perpendicular to this surface, so I know even though there's a bit of an angle on this and I've got a curved surface, it will go in and fit accurately. So to do that, I'm going to set it down here. I'm going to leave my setback spacer there, and I'm going to use this little shim wedge underneath it. Now I'm going to just loosen my square so I can put it flat. Okay. Now I just want to set this up so that, can you see right in there? I want to see that that is true. Now I need to raise it up just a little bit, so I'm going to move my shim in. So whatever you're working on, you just want to shim it up or whatever so that you know the cutter is going to come in perpendicularly to the surface. All right, I'm still want to move it up a little more. Just a touch more. That's sitting nice and flat now, okay? Right off there, that's good. So I want to get my clamp. Move my board a little bit more, okay? And I'm just going to hold this down just like I did the other one. Double check. Looking good. Yeah, that looks good. All right, so now I'm going to use my little riser piece. This is the top of it. I'm marking the location of the mortises that we're about to put in. So I just needed to get those back. All right, here we go. I'm going to go ahead and plunge the same way, this time into a curved rail, the end of a curved rail that we've got indexed. And look at that. So quick, right into the end. Push in our dominoes. And go into our seam mortise. And look at that. What a fit, huh? Nice little setback. So just think about this. You could laminate and make a round apron. Like you could make a, you know, the rounded apron. So you draw this out from the top. draw a large circle, and you could have your 4 legs placed, and just by using that technique, laminate your apron, and you can get a beautiful curved apron in a circle or whatever. It's super slick and easy. The last method I wanted to show you is, this is the outdoor swing project that is in all white oak. Now this entire piece was actually traditionally mortise and tenon. You can see on this end here how there's a tenon, there's actually a peg right there. This is really an honest swing. I mean, this baby is going to stay together for a long time. But when it came to these backrest pieces, they have a curve in them. So they come up and they swing over and they curve, and they all have to be exactly the same length, because when you clamp it together, you have to clamp this assembly together this way before you can then clamp it this way, where you've got your tenons on the end. So if you clamped it this way and there was 1 or 2 short, you'd see them gapping out somewhere. So what I did was, in building this piece, was I set up some stops that were on riser blocks so it would hold it accurately, and cross-cut with stops. So I cut them all identically. But could you imagine doing that and then having to cut tenons on the end of these? So this was a great candidate for floating tenon. So I think I used the 10mm floating tenons in these, and it was great. I had a little jig set up that held each piece perpendicular, like at a right angle. Excuse me. So I just plunge right in perpendicular to the surface. And I just very quickly cut all those mortises, glued all those tenons in, and this was a breeze to glue up. I was able to just glue them all quickly, push it together, put a clamp on, everything came up beautifully. Even though those shoulders are not at a true 90, because I put the tenons in at 90 degrees to the surface, everything came up and fitted great. And of course I used the same layout stick showing all the locations on the underside of this rail, and used the domino for that too. Really great, sweet. Keep your eye out for places where you can use a floating tenon, and you can save yourself a lot of time and get a really great, strong joint.